Good morning, my dear students. I am Dr. Manjunath, working in the Department of Business Administration, SBRR Mahashana College, Autonomous, Mysore, University of Mysore. Today, I am here to deliver a lecture on assignment problem. It is a kind of a unique kind of transportation problem, and it deals with the allocation of resources. Basically, the jobs and employees, the machines and operators, maybe the machines and jobs, likewise, the resources and the facilities can be matched so that the overall cost of allocation gets a minimum. D. Koenig, a Hungarian mathematician, developed a method called as Hungarian method of solving assignment problem. And Hungarian method addresses the concept of what is called as zeros or gems. It means to say that we need to have utmost care with regard to the zeros that we're going to derive in the course of the simplification procedure or the iterations which are supposed to be developed during the row minima, the column minima, and the optimization procedures. There are three different steps. One is row minima operation, the column minima operation, and the optimization iterations. There are two types of assignment problems. One is called as balanced assignment problem, where a number of rows is equal to a number of columns, or we can say that it's a kind of square matrix. It's a square matrix here. And in the case of unbalanced problem, rows and columns, they're not same. Here is an example which deals with resource allocations with regard to the softwares supposed developed by three different software programmers or the experts. It says that there are three different software programs to be developed by three different software programs or the engineers. This matrix represents the cost or the unit cost. Program 1, if it is allocated to A, that is going to incur 120 rupees of the cost, and 1 is allocated to B, that is going to be 100. Now 1 is allocated to C, that is going to be 80 rupees. Generally, maybe it is units or maybe in rupees. Generally, I consider this as rupees here. Now, row minimum operation, we are going with step number 1. It speaks about take the difference of the minimum with regard to each and every row. Now, if we say that 120, 180, the minimum is 80. The second row, the minimum is 80 again. The third row, the minimum is 110. If we take the difference, 120 minus 80 is 40. 100 minus 80 is 20 here. 80 minus 80 is 0. Similarly, I am going to perform the row minimum operation for second row. 80 minus 80 is 0. 90 minus 80 is 10. 110 minus 80 is 30. Now, the third row, similarly, 110 minus 110, the difference is 0. 140, 110 is 30, difference. 120 and the difference of 110, the difference is 10 here. That is step number 1 completed. And going for step number 2, it is column minima operation. The column minima operation is a continuation of your row minima. And if you say that first row, here the first row and the first column, it is compared. Now go with this the first column. The first column says 40, 0 and 0. 0 is the minimum. 0 is the minimum. There is no alter in this column minima. And if you go with the second column, the column minima here is 10. Look at this, 20, 10 and 30. The minimum is 10. And this 10 is to be subtracted now. That is 20 minus 10 is 10. 10 minus 10 is 0. And next 30 minus 10 is 20. We have the second column minima is done. And similarly for the third column, 0 is the minimum. There is no alter. It remains same. Now go with the allocations now. In the first row, we have only 1 0. The second row, we have 2 zeros. And the third row, we have only 1 0. The procedure says that target the rows having only one zero to begin with, and then put an allocation over it, for that particular zero. Now if you say first row, it is allocated. Now the square box is there and it is allocated, and after allocating, look for any other zeros in the respective row and the respective column. If it is there, you have to discard it. But here there is no such kind of discussion, that is discarding of zeros or cancellations. Now if you go with the second row, we have two zeros. Just skip for a while, and I'm just continuing with the third row, and I have only one zero here, and it is allocated. Now once this allocation is marked, there is a zero in the respective column, just discard it. And once this zero is discarded, we have left with only one zero here in the second column and with respect to the second row, and this is the zero here, and it is allocated. Now we have three software programmers, and the three software programs to be allocated, and there are three allocations. The optimization reached. It says that the optimum allocation of the schedule is software 1 is allocated to programmer C, it is here. Software 2 is allocated to B, and software 3 is allocated to A. And if you compare with the first page or with a given problem, minimum cost is going to be 1 with C, 2 with B, and then 3 with A. It is going to be, look at this, 1 with C, 1 with C, this is 80. Again 2 with B, it is 90. And again 3 with A, it is 110. That's what it is marked here. It is 80 plus 90 plus 110. The total is 280 rupees. The cost minimum is 280. This is the cost minimization by using Hungarian method. And this is your optimization schedule. 1 is allocated to C, 2 is allocated to B, and 3 is allocated to A. And that's it. Thank you very much.